Hi, welcome to the mathcenter.com. In this video today, we are going to be looking at a question from the Pure Maths paper P3 CIE. Subject code is 9709/03 because this question is taken from the Specimen Paper 2020. Again, this is Pure Maths 3. The exam is tomorrow. So I thought for us to get a booster on questions like this, a quick review. Yeah. Okay. Please share this video as much as you can. Give it a like. Please follow me on Facebook and YouTube for details of the courses that we offer. Please visit the mathcenter.com. We offer a whole range of maths and further maths courses online. Okay. Let's look at the question. By the way, a full solution, my solution will be given as a link to this video, so you can follow it without any problem. I have summarized the question on the board so that we just have what we need so that we can talk about the solution. Okay, so we are given x equals to e to the power of 2t minus 3 and y equals to 4 ln t, and you're told that at t equals to a the gradient is 2, and you're asked to show something, okay, some equation. Let's start slowly. Yeah. So we have got x equals to e to the power of 2t minus 3. So dx dt will be equals to 2e 2t minus 3. Yeah. Remember, we have a e to the power of fx. When you differentiate, you will get f prime x e to the power of fx. Finish. Yeah. And then I have y. Let's write it here. 4 ln t. That looks easy enough. So dy dt will be 4 over t. So now they gave me the gradient at t equals to a, so I need dy dx. Yeah? So dy dx will be equals to dy dt times dt dx. Chain rule. So dy dt 4 over t, dt dx, that will be 1 over 2e to the power of 2t minus 3. Let's do a bit of cleanup. 4 and the 2, we will have 2t e to the power of 2t minus 3. That's dy dx in terms of t. Let me quickly check that. Yeah, 4 over t, 2 and t, and yeah, looks good. So when t equals to a, you are given dy dx equals to 2. Let's plug that in. 2 equals 2 over a e to the power of 2a minus 3. Let me get my eraser. Okay. So from here, let's clean up a little bit. This is 2 and 2, so we can have, let me write it here, 1 equals to 1 over a e 2a minus 3. We can cut short the working, but let's just do it properly. Yeah. Okay. So now we are almost done. So I have got a e to the power of 2a minus 3 that equals to 1. Okay. So I have e to the power of 2a minus 3 is 1 over a. Taking logs, I'll have 2a minus 3 equals to ln 1 over a. Okay? What is ln of 1 over a? Minus ln a. Okay? What is ln of 1 over a? Minus ln a. So now let's clean that up a little bit. We have got 2a will be equals to, bring the 3 across, 3 minus ln a. Therefore, a equals to a half 3 minus ln a. There you go. Okay, and we are done. So that's the first part, and let's quickly breeze through the next two parts. They're very easy to do. Just a bit of calculator work on the last part. So you have an equation, a equals to half 3 minus ln a. You're asked to show this equation as a root between 1 and 2. That's one of the easiest things you can get on the exam. So a good way would be let f of a be equals to a minus a half 3 minus ln a. Yeah, let f of a equals to a minus half 3 minus log A. Yes, I copied it correctly. So between 1 and 2, well, 1 you just plug in 1 minus a half, 3 minus, what is log of 1? 0. So I have a 1 minus 3 over 2. Okay, I'll have a negative half. And f of 2 will be what? 2 minus a half, 3 minus log 2. Okay, just plug in, yeah, 2. And then I have log 2 here. And this one here, when you use your calculator, you get a positive value, 0.84 something. Okay, so since, okay, make sure you write this line on the exam, yeah? Since f of 1 and f of 2 are of opposite signs, okay, you must write this line, yeah? People don't write this line, yeah? They assume that the examiner knows what you're thinking. So since f of 1 and f of 2 are opposite signs, one is negative and one is positive, opposite signs, there is a root between 1 and 2. So make sure you write that line, okay? Good. They ask you to show and we are done with that. And the last part, let me just quickly tell you a little bit about this, okay? They ask you to use, okay, an plus 1 equals to a half 3 minus ln a, excuse me, an, okay, to find the root of this equation. That's about it, yeah? So this is what we study in what? Iteration, yeah? So an plus 1 equals to half 3 ln an. You need a starting value. They didn't give you a starting value. But that's not difficult for you. If you want, what you can do, right? You can look at this. You know there's a root between 1 and 2. You can start with 1.5. You can start with there's nothing wrong with it. Yeah? You can start 1.5. Or you look at this. This is negative 0.5. This is 0.8. Okay? This is negative 0.5. This is 0.8. So it's closer to negative 0.5, the 0. So you can choose a value which is nearer 1. Maybe instead of going 1.5, you can take 1.3. The only advantage you may have is you may do lesser iterations to arrive at the answer that they want, to the degree of accuracy that they want. Okay, that's the only advantage. But if you have any problems, just take the midpoint, 1.5. So which means you can start with a naught, the starting value as 1.5. Okay, and then you go on to a1. Just plug in, yeah. Just take 1.5, plug it inside here. You will get a1, a2, and so on. And then finally, your answer to this question, you will get 1.35, yeah, to 2 decimal places. 1.35. But don't forget, you will check this though. So you must come back to your f of a equals to a minus a half 3 minus ln a. You want to make sure that it's correct to 2 decimal places. So you check what? 1.35, so this is 1.345, and check 1.355, and these, make sure, show the working must be of opposite signs. Then you know that you've got your answer, 1.35 correct to 2 decimal places. Okay, that's the end of the problem. Thank you very much for watching. Please give me a like and share this video as much as you can. Follow me on Facebook and YouTube. Good luck on the exam tomorrow. And for details of the courses, please visit my website, themathcenter.com. Thank you.